All right, here is an overview of Mission 1, Lesson 13. Sorry, I started off kind of slow there. My brain was wandering. All right. Our student objective for this lesson is let's use place value understanding to decompose to smaller units once using the standard subtraction algorithm and apply the algorithm to solve word problems using tape diagrams. And I know right now you read that, you hear me say that, and you're thinking, oh, what? What does that mean? That's a bunch of mumble jumble. And you're right, it does sound like a bunch of mumble jumble, but let me give it to you a little straighter, a little easier. What that's really saying is, hey, we need to be able to subtract, and we need to be able to borrow when we subtract. That's what we need to be able to do today. We need to be able to subtract and borrow. All right. Now, if I'm given a subtraction problem, and I want to solve this using the standard algorithm. Okay. Now, reminder, in subtraction, our greater number, that is considered our whole. The top number is considered our whole number. Because we have the whole number, and we're going to take something away from it. If you are given those two numbers, it matters when you are writing the equation which number goes on top. Okay? The greater number goes on top. You have to. In addition, you can kind of rearrange. It doesn't matter what order you put the numbers, what number you put on top, it really doesn't. Subtraction, it is important. You have to have the greater number on top. So, and that greater number is our whole, because we're starting off with some number, and then we're taking something away from it. We're taking away a smaller number away from it. So, you've probably used borrowing before with subtraction. Okay. What you're going to find in this lesson, they'll have you use the place value chart, and they're going to call it unbundling. Unbundling. You're going to see how using the place value chart that you're actually, when you borrow, you're just unbundling from that next place value. You're just taking one there. So you're going to see that. Now, something that I know Zern does differently than the way that you've probably been taught to do subtraction and the way I was taught. It has you, the way I was taught was this, right? I start here, because you got to start with your lower place value. 7, I would do 7 minus 4. I would solve that. I would do 8 minus 3. I would solve that. I would go on. Zern wants you to go through all the numbers first and see if you need to borrow. It wants you to do all of your borrowing first and get that out of the way. So again, that might be different than the way you were taught, and the way I was taught to do it was you work through each step, and then you'd borrow, and then subtract, and then you borrow, subtract. Zern's going to want you to do all your borrowing first. So what we're going to do is we're just going to ask the question here for each one. We're going to start with our ones place. Can I do 7 minus 4? Yes, I can. I can have 7, and I can take away 4 from it. Okay. Can I do, now to the tens place, can I do 8 minus 3? Can I take away 3 from 8? Yeah, I can do that. 8's greater than 3. I can take away 3 from 8. Can I do, okay, let's go to the hundreds place. Can I do 4 minus 6? That sound effect that I just made tells me, oh, I cannot do that. I cannot do that. I can't do 4 minus 6. Why can't I do 4 minus 6? I can't have 4 of something, and then take away 6 from it. I don't have enough. I only have 4. I can't take away 6 from there. Sad day. Sad day. So what do I need to do? I need to borrow or unbundle. So I don't have enough hundreds here to subtract. I can't take away 6 hundreds from 4 hundreds. So what do I need to do? I need to borrow or unbundle. So I go up to my next place value, which is the thousands place. And what I'm going to do is I'm going to take 1 away from there. So that 6 becomes a 5. Because I went from having 6 thousands to now have 5 thousands. And that 4 becomes a 14. Why does it become a 14? Well, I just need to add 10 to whatever the original number was. When I borrow, I add 10 to it. Once we look at our place value, if you remember, it takes 10 to move up one place value or down one place value, right? So what I did there, I just unbundled one of those thousands and took one of those thousands, became 10 hundredths. And so I took that 10 plus that 4, and I ended up with 14. Okay. Now can I do 14 minus 6? Yeah, I can do that now. Can I do 5 minus 5? Yes, I can do 5 and take away 5 from it. Can I do 1? Take away 1? Yes, I can do that. Now I can solve. Notice I did all my borrowing first, and now I'm going to go through and solve. So I'm going to look at it. 7 minus 4 is 3. 8 minus 5 is, 8 minus 3 is 5. And again, so I'm just starting my lower place value and working my way up. 14 minus 6. If I have 14, I take away 6. That's 8. Put my comma right back down there. 5 minus 5 is 0. And then 1 minus 1 is 0. So that's actually nothing at all. So what is my difference? 853. Difference, when you hear the term difference, that means, hey, what's the answer to a subtraction problem? Answer to a subtraction. Sum, when you hear the term sum, that means the answer to an addition problem. Difference means the answer to a subtraction problem. So the difference here is 853. Okay. Now, we do need to be able to use tape diagrams for this today. Let me see here. I'm going to erase this. So a tape diagram for a subtraction problem is going to look like this. Now, this is going to be a pretty simple problem, but just to get the point across. So let's say I had, I don't know, apples. Yeah, why not? Apples. Let's say we had, gotta change that color. And gotta choose this. Let's say I had 342 apples. And Billy ate, let's say he ate 27 of those apples. Geez, Billy must have been really hungry. I hope this is not in a one-day sitting. So, if we draw a tape diagram for that, okay, what is the information that I know? Okay, I know that I started off. Oh, and then I should be clear. If there are 342 apples, Billy ate 27. The question's going to ask something like, how many apples are there left? How many apples are left? I apologize for the millionth time about my handwriting. All right, so how many apples are left? So let's get a little line over here. Okay, so what do I know? Well, I know my total. And my total is 342. Remember, when I was using addition, a tape diagram for addition, that top numbers was my total when I'd add these two numbers. Well, in this case, subtraction is different because I know the total. And I know some of the pieces. I just don't know all the pieces. So if I had 342 as my total, and Billy ate 27, okay, and then how many apples are left? Well, we don't know. But we know whatever Billy ate, that 27, together with how many are left, which we don't know, should equal 342. So these two together should equal 342. Well, how do we figure that out? Well, for it's a subtraction problem, to figure out this missing piece, we would subtract. We would take our total, 342, minus the piece that we do know, 27, and then I'm going to go through. Can I do 2 minus 7? I cannot. I have to borrow. That 4 becomes a 3. That 2 becomes a 12 because I'm adding 10 to it. Now can I do 3 minus 2? Yes. Can I do 3 minus, if there's nothing there, it's just 3 minus 0. I can do that. So now I do 12 minus 7 is 5. 3 minus 2 is 1. And 3 minus 0 is 3. 315. And how can I check my work? I can check my work by, if I add these two together, I should end up with 342. So if I take my two pieces, 315 plus 27, 5 plus 7 is 12, carry the 1. 1 plus 2 is 3, plus 1 is 4. And then 3 plus nothing is 3, 342. That's how I know I did that correctly. Okay. So, in summary, subtraction, we're borrowing. Okay. And then we're going to have to set up a tape diagram with it. But the difference with tape diagram and with subtraction we know the total and we know at least one of the pieces. And then we have to figure out the missing piece.